In question number 3, we're going to continue the previous conversation about the two-part recursive definition so that you can see what exactly we need to do in order to thoroughly define an equation that not only matches the one that we're given, but guarantees that we're only going to get these numbers. Because the pattern itself, like if the pattern is plus 5 in the example we just did in the previous video, doesn't tell you where to start. And if I just said, hey, think of a sequence that has plus 5 as its pattern, we don't all necessarily think of the same sequence. And that's not good. We don't want that idea in math that somehow we could all be thinking of different answers and we'd all be right, because then it would just be chaos. So the importance of having a two-part definition is guaranteeing that we all start in the same place and that we all think of the same pattern. For example, this series or sequence tells us to start with a 3. Now we're just going to call that the first term because it is literally the first thing they give us. And we're going to say, to write it clearly, t of 1 equals 3. Now that means because it's the first term, the n, the inside of the parentheses, is 1. So this is how we would write it. If you were more comfortable with the table format of things, especially if this is how you're used to seeing sequences now, you could translate this sequence into a table. So you could say the first term is 3, the second term is 9, the third term is 27, the fourth term is 81. And of course, it's a little bit more obvious now that t of 1 is like saying n is 1, and then the actual value is 3. So that's the first part that we write. This is what we call the specific term in the sequence. You can technically call out any specific term you want to. It doesn't have to be the first term, but you'll find that customarily it's just the first term because it just makes sense. Like the first one they give you is usually the first one you write. Now the next part always starts with t of n plus 1. Then we say equals. And this is where we say what the pattern does. So let's look at the actual pattern of numbers, 3, 9, 27, 81. I have to think, like, what could be happening here? Is it arithmetic, geometric? It doesn't say. But I got to think, how do I get from 3 to 9? Well, I could add 6. Well, that doesn't work to 27. So what's another way to get from 3 to 9? I could multiply 3. 3 times 3 is 9. Ooh, and 9 times 3 is 27, and 27 times 3 is 81. So it looks like times 3 is the pattern. And the way we write that in our recursive equation is to say t of n plus 1 equals. Then we say t of n, that's our current term, times 3. So basically to write the equation part, just say t of n, and then write what you would have to do to get the next number in the sequence. If to get the next number in the sequence you would multiply 3, then notice I wrote that really literally, times 3. So this is always the structure that you use. T of n plus 1 equals t of n, and then whatever operation you need. Plus, minus, divide, multiply, anything that you need to do. So in question letter B, same idea. Let's see if we can do it the same way. Now, as you start to do these more and more, you probably kind of wean yourself off of some of the habits. And one of the things you might not have to do is write a table or anything. You might immediately say to yourself, oh, 17, that's the first term, because it's literally the first number they're giving me. So I could go straight to saying t of 1 equals 17. Notice first term is always called t of 1. Then we could write t of n plus 1 equals t of n, because that's always the same. And then I'm just going to look at the pattern really quickly. 17, 15, 13, 11. Looks like it's subtracting by 2, so subtract 2, and there's my equation. So it goes pretty quickly once you know what to write. It definitely goes a lot faster once you know what you're doing. I'll do one more, again, just to prove to you that you can kind of see how quickly it goes. Let's look at letter C. First term they're giving us is 96, so t of 1 equals 96, that's set. And then we say, okay, t of n plus 1 equals t of n, and then we look at what's happening in the pattern. It looks like this pattern is dividing by 2 each time. So I would say t of n divided by 2. Now you could also write, because some people prefer this notation, t of n and then dot dash dot, the old school dividing notation, that's fine as well. Both ways are acceptable, both ways will work. Either way, try if you can letters D, E, and F using the basic setup and seeing if you can get yourself used to writing these two-part recursive definitions.